Greetings, math fans. This is day 12, and we're going to talk today about derivatives of trig functions. So let's start off with the first one here, d by dx of sine of x. Alright, so I'm going to go back to limits, okay, which actually is something you'll recognize because we just did that at the beginning of this chapter, which you definitely need to know using the definition of the derivative. So we're going to say that's equal to limit as h approaches 0 of sine of x plus h minus sine of x all over h. Okay, hopefully you remember that. Now, math fans, you guys should recognize this is sine of x plus h, right? That's sum and difference of sine, and hopefully you remember that. So it's limit as h approaches 0. That's sine of x. Remember, it's sine of a plus b is sine of a cosine of b plus cosine a sine of b. Okay, so we're going to, obviously we're just using x's now here. So sine of x cosine of h plus cosine of x sine of h. And remember, it's plus because same sign, minus sine of x all over h. Okay, then what I'm going to do is I'm actually going to group this guy and this guy together. Alright, so I get sine of x cosine of h minus sine of x plus cosine of x sine of h all over h. Okay, then what I'm going to do is I'm going to factor a sine of x out of this first group right here. Okay, so I'm going to get sine of x times cosine of h minus 1. And let's keep going here, plus cosine of x sine of h all over h. Okay, I'm going to cursor down here a little bit. So limit as h approaches 0. Now what I'm going to do is break this up. Okay, so I'm going to get limit, this is going to be sine of x times limit as h approaches 0 of cosine of h minus 1 over h, and then plus limit as h approaches 0 of cosine of x times limit as h approaches 0 of sine of h over h. Okay, so kind of just make sure you know what you're doing here with this, right? But basically I broke it up into two separate pieces because if I have this plus sign over here, right, it's basically two limits, two separate limits, and then I gave this guy, let that h go with that h on top, the cosine of h minus 1, and then for the other side I said this sine of h went with that h. Okay, so that's kind of how I broke that up. And now you guys should recognize a couple different things here. First of all, this is something from way back when. Alright, and you should recognize that this is when the limit as h approaches 0, this goes to 0. And you should recognize this, limit as h approaches 0 of sine of h over h, that goes to 1. So let's keep going here. We have limit as h approaches 0 of sine of x times 0 plus limit as h approaches 0 of cosine of x times 1. Okay, and of course limit as h approaches 0, it doesn't even matter what's going on here because what sine of x isn't limit as h approaches 0 of sine of x, it's still sine of x, right? Because it's not like it's saying x is going to 0. So do you guys agree it's just sine of x times 0? And same thing with this one. Limit as h approaches 0 of cosine of x. Doesn't matter what h is going to, it's still cosine of x times 1. So this goes to 0, and I have 0 plus cosine of x, which is cosine of x. So, math fans, d by dx of sine of x equals cosine of x. Okay, you need to put a couple stars around this because this is a really, really important derivative for this trig function. Okay, but I want to show you real quickly. Let's just look at this spot right here, and let's graph sine, and then let's graph cosine. So cosine is going to look like, let's put a couple of marks here just to help graph it nice and neatly. Okay, so we're going to graph it, and it's going to look like this, like that, and like that. Okay, so remember, in this spot, let's kind of look at a couple spots here. Do you guys agree at this spot right here? What's going on? Isn't the slope positive? Well, look at that red line. Isn't it positive over there? Okay, and what happens if when you hit a peak? Isn't the slope 0? And sure enough, there it's 0. Okay, and then the slope is negative from this point here. Slope is negative, and look at where the red line is. The red line is negative at that point too, and then all of a sudden the slope is 0 again right here, and there it is. The slope is 0 right at that point, and then it becomes positive, and sure enough, there it is. It's positive. So the slope, you can tell just by looking at the graph, the slope of the sine graph is the cosine graph. That's why it's the derivative. Okay. All right. Let us do cosine. Okay, so it's d by dx of cosine of x. We're going to do the exact same thing. We're going to say that's equal to the limit as h approaches 0 of cosine of x plus h minus cosine of x over h. Okay, and now we're going to do the same thing for cosine of x plus h. Okay, so limit as h approaches 0, and cosine of x plus h is cosine of x, cosine of h, and then it's minus sine of x, sine of h. And then it's minus cosine of x all over h. Okay, we're going to do the exact same thing. I'm going to group this guy and this guy together. So I get limit as h approaches 0 of cosine of x, cosine of h, minus cosine of x, minus sine of x, sine of h, over h. Okay, then I'm going to factor out cosine of x. So you get cosine of x times cosine of h minus 1 minus sine of x, sine of h, all over h. Okay, let's keep cursoring down here a little bit. Okay, so now I'm going to break up the problem just like I did before. So I get limit as h approaches 0 of cosine of x times limit as h approaches 0 of cosine of h minus 1 over h minus limit as h approaches 0 of sine of x times limit as h approaches 0 of sine of h over h, right? So we have all our parts here. Everything's good. We just use our properties of limits to break it up. And let's figure it out. Let's keep going here. Limit as h approaches 0 of cosine of x. Okay, what does this equal? Right? That equals 0 times 0 minus limit as h approaches 0 of sine of x. And what does this equal right here? Okay, that equals 1. So we have limit as h approaches 0. This is just going to be cosine of x times 0 minus sine of x times 1. So that goes to 0, and we have negative sine of x. So d by dx of cosine of x equals negative sine of x. That is super important. Okay, so again, a little weird way to remember things. If you say take the derivative of sine of x, it's the same sign. So it's cosine of x. Okay, and the derivative of cosine of x is the opposite sign. So it's going to be negative sine of x. Just a goofy way to remember things. All right. Let us do a couple examples here with that. All right, so here's an example. Y equals 2 over x minus sine of x plus 3 over cosine of x. All right, so let's use some properties here. We're going to do y prime is equal to, let's use the quotient rule. Two ways you can do that. You can use the quotient rule, or you can write that as 2 times x to the negative 1 and use the product rule. Okay, so I'm going to use the quotient rule just because it's set up that way. So I'm going to do the bottom times the derivative of the top, which is 0, minus the top times the derivative of the bottom, which is 2, all over the bottom squared. Okay. Derivative of sine is cosine, so it's minus cosine of x. And then I'm going to do the quotient rule again. So it's plus the bottom times the derivative of the top, which is 0, minus the top times the derivative of the bottom, so minus 3 times negative sine of x all over the bottom squared. Okay, so let's simplify that. So we have negative 2 over x squared minus cosine of x, and then that's plus 3 sine of x over cosine squared of x. Now, that last part, so this is good. Minus 2 over x squared minus cosine of x. And this one you want to simplify. So just remember that's 3 sine of x over cosine of x, cosine of x. So what do we have here? We have my plus 3 tangent of x. And then please don't leave that as a denominator. 1 over cosine of x is going to give you secant of x. Okay, and that's our answer. Pretty reasonable, right? Okay. Let's do another example. Find the equations of the line, or of the lines, tangent and normal to the graph y equals x cubed cosine of x at x equals pi. Okay, so it's pretty easy. Just got to take the derivative, right? We're trying to find the slope of the tangent line. So dy dx is going to be, we're going to use product rule. So it's going to be the first x cubed times root of the second times negative sine of x plus the second times root of the first, which is 3x squared. Okay, and let's just kind of write it nicely here. We have negative x cubed sine of x plus 3x squared cosine of x. Okay, that's our dy dx. All right, that's pretty mellow. And let's find our slope then. So that's our slope of that tangent line. And we're going to plug in pi. So it's negative pi cubed sine of pi plus 3 times pi squared cosine of pi. Okay, you guys should remember what sine of pi is. If you remember, sine of pi is 0. So it's negative pi cubed times 0 plus 3 pi squared. Cosine of pi is negative 1. So that's 0, that's out of there, and so my slope is negative 3 pi squared. Okay, and now I need to find the equation, so I need to find my xy coordinate. Well, I have my x coordinate. Remember, math fans, make sure you plug this into this equation here. All right, the original equation. Don't plug into the slope equation. That's not very good, because if you plug into the slope equation, well, it doesn't make sense. You're trying to find a y coordinate. All right, so let's do that. Y is equal to pi cubed times cosine of pi So y is equal to, cosine of pi is -1, so it's negative pi cubed. So that's your coordinate. So it's pi, comma, negative pi cubed. Alright, and let's get our equation here. So the tangent line is going to be y plus pi cubed is equal to negative 3 pi squared times x minus pi. Again, make sure you give it to me in point slope form. It is silly to give it to me in any other form because it's so easy. You have a point and a slope. And then, of course, when you write your normal line, that makes it so much easier. So y plus pi cubed equals going to be positive 1 over 3 pi squared times x minus pi. Very easy. Okay? That's it, math fans. That is the derivative of the two functions that we're talking about today, the derivative of sine and derivative of cosine. All right? That's it. Have an outstanding day. Adios. Goodbye.